of that word up there? Partition. Partitions. You ever heard of it anywhere? Ever been to the library and sat in one of those little study carrels there all by yourself? No? You know what a library is? You read. Or just watch movies, I guess, right? Here. Partition is you're breaking, separating it. All right? I don't know if you've ever seen actual partitions. We should probably bring it up instead of me trying to draw it, because that's going to be a disaster. In real life here, before we go to math here, partitions. Divides things up here. All right, like cubicles, almost like in an office. They set up partitions to divide people up. Okay, so that's what the word partition means, is that we're going to divide things up. Specifically, we're going to divide line segments up today into certain ratios. And let me just first talk about the directions. All the directions we're going to have today are going to refer to this, directed line segments. All right, directed line segment AB. What does that mean, directed line segment AB? That means you go from A to B when I do this breaking up of the lines. Because if I go from B to A, I'm going to get a totally different point. All right, so directed line segment AB tells me you starting point at A, ending point at B. So I just want to hop right in here with some different examples. Let's get my notes here real quick. All right, I want to break this AB in a ratio of 2 to 3. Yesterday we had 2 to 1 for the median, right? Break it up into 2 to 3. How many equal parts is that going to be? 2 to 3. How many equal parts am I going to break this up in total? 5. Everyone agree? So let's try to break this up into 5 equal parts. 1, 2, 3, 4. So just eyeballing it right here, broken that line segment AB into 5 equal parts. Now, can we find the point on there that would break it up into a ratio of 2 to 3? I'm going to put a point P on here right now that would break this line segment up in a ratio of 2 to 3. Can we see out of all the points I put on there, which one would do the job? Which one would break it up into 2 on the left, 3 congruent parts on the right? Can we see that point and put a P there? Yes, no, maybe? Okay, so where is it? It's going to be right here. Okay, right there. Point P breaks it up, and then everyone do you see the 2 to 3? Everyone sees that. 2 parts to the left, 3 parts to the right. All right, let's keep doing this exercise before we actually go to a graph now. Let's break 3 to 2 now. Let's flip it for this one. 3 to 2. Still breaking AB into how many equal parts? 5 equal parts. Can you guys find point P for me that breaks it up into 3 to 2 now? 3 to 2. All good? Couple more just to make sure we got the hang of this. I'll change the ratios. 1 to 2. I want to find a point on AB that breaks it up into 1 to 2. Now, how many equal parts am I breaking AB up into? 3 equal parts. Yep. So let's break it up into 3 equal parts first. And can you put point P where it would break it up into 1 to 2? First or second point? First, yep. Good, we're getting the hang of this. A couple more, how about 4 to 3? Let's break it up 4 to 3. So how many equal parts now? 7 equal parts, yep. Not the greatest, but. And then can you find the 4 to 3 one? 4 to 3? Oh, hungry for one more? Sure. Uh-oh, is everyone all right that it's a little slanted and not horizontal? 1 to 4. Let's go 1 to 4. Find the point that breaks it up into 1 to 4. How many equal pieces now? 5, right? And hopefully we put point P right here at the first point, 1 to 4. Now, do you notice how directed AB is different from directed BA? Because if I went directed line segment BA, that point would be here now. Okay, but most of the time, almost 100% of the time, it'll be directed line segment AB. Everyone all right? Because here's what we're going to do now. We're going to do it on a graph. And actually, I actually want the XY coordinate that breaks it up. All right, so let's try this out. I got to get the new stuff up here. All right, go ahead, graph that line segment. Okay, let's graph that line segment, and then we'll talk. Yep, nice little straight edge coming out. All right, you ready? I need to break this up. I need to find the point. Where on this line, I don't know. Where on this line, I don't know yet, is going to be the point that breaks AB up into a ratio of 2 to 3. First thing I want to figure out is, all right, if I'm finding the point that breaks it up in 2 to 3, how many equal parts do I need? I first need to break AB up into how many equal parts? 5 equal parts. Yep. So that's the first thing I just want to determine. 5 congruent parts. And not only are you going to do that on the x-axis, you also have to do it on the y-axis. All right, I need to break the x-axis up into 5 congruent parts, the y-axis up into 5 congruent parts. So let's start with the x-axis first. All right, let's start with the x-axis. From A to B on the x-axis, how many units am I moving? Let's first determine that. You can either count on the graph, or you can do it algebraically, going from -3 to 2. How many units on the x-axis am I traveling to get from A to B? Everyone agrees 5, whether I count it, 1, 2, 3, 4, 5, or I look at the coordinate, -3 to 2 is 5 units. So everyone agrees here, I'm going 5 units on the x-axis. Agree? And you need to divide that 5 units up in how many equal parts? 5, right? So every time I go 1 unit, I'm dividing it up. Here's what I mean. Ready? I start at A, I go 1 unit on the x. There's 1 part, 1 unit. Go over 1 unit. There's another point. Go over 1 unit. There's another point. See how I'm dividing that up evenly now? Over 1 unit. Up. There's my point on the line. Go over 1 unit again. There's another point. Next, because I want to do this algebraically and on the graph. And then you can choose what's best for you to do. How many points do I have to go over? if I'm going to break it up in a ratio of 2 to 3. Ready? I went over 1. Is that point acceptable? Is this point acceptable for 2 to 3? 2 to 3. Is this point acceptable? No, I got to go over how many times? Twice, right? So what I'm trying to show you guys is every time I move 1 unit. But I got to do it twice. So in total, how many units on the x-axis am I going? 2 total units. Does that make sense? That to break it up, I need to go 1 unit at a time, but I'm trying to get to this 2 to 3 point, so I just don't go over once, I got to go over again for a total of 2 units. Where did I start on the x-axis? Where did I start on the x-axis? Where did I start on the x-axis? -3. No, not 4. -3, right? On the x-axis. I started at -3, and you guys just went over how many units? Well, all the way to the end, but how many units do I need to move to hit to this 2 to 3 point? 2 units. So -3, I went over 2 units. Where's my ending point? -1 on the x-axis. So I know my x-coordinate is going to be -1. What about my y-coordinate now? And this is going to be uncomfortable at first until we do a ton of them. Y-coordinate. Now do the y-axis for me, from A to B. From A to B on the y-axis. How many units did I go? 4. 4 units total. How many do we have to divide it up into? 5 equal units. Uh-oh, this isn't going to get pretty, but thank God we have calculators. That means I got to go how many units each time? 4 divided by 5. 0.8 every time, right? So listen, ready? I go 0.8, 0.8, 0.8, 0.8, 0.8. I get to the end. Where do I want to be, though? I only want to go 0.8 how many times? Twice. See how this is going? I don't want to go 0.8, 0.8, 0.8, 0.8 to the end. I only want to go twice because I got to hit the 2 to 3 point. So I'm going to go twice. So how many total units should I be moving on the y-axis? 0.8 times 2, 1.6. So that's telling me how many units I have to move. Where did you start on the y-axis? Where did we start on the y-axis at? -4. And you're going to go up 1.6. Where do you end on the y-axis? -2.4. So where was my point that broke it up into a ratio of 2 to 3? -1 on the x-axis and -2.4 on the y. Do a quick check. Is that point on my line? It better be. Is that point on my line segment? -1, -1, 2, and about 4. Yeah, look at right there. We could find it on the graph, but we couldn't find probably the exact coordinate without doing the algebra behind it. So let's review real quick before I go on to the next one. I need the total distance on the x and the y. Total distance. Divide that by however many parts you're breaking it up into. In this case, we divided it by 5. Then figure out how many times you're going to go 0.8. How many times you're going to go 1 unit on the x-axis. That will all be determined by whatever the ratio is. That's why I multiplied by 2 every time. Because I had to get to the second point on the line segment. Questions? Again, I'm going to start calling on people too after this one. Questions here? Okay, let's go to the next one. One doesn't make you great. And you're going to start getting, of course. All right, let's go. Hurry up. This is such a pain. Nobody even noticed either. It was like 2 out of 13 of you. Pinwheel. And I know this isn't the problem we're doing either. I don't want anybody watching this. Resume play. -2, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3. Uh, 4 to 1, as you guys are graphing this, 4 to 1. How many equal parts is it going to get broken up into? 5 congruent parts, yep. The X and the Y, remember. When I say that, I mean the X-axis is getting broken up into 5 equal parts, and so is the Y. It might not be pretty in a whole number, but it is. So let's start on your X-axis first. X-axis, how many total units on the X-axis is this line? 4? Everyone agrees 4? So it's 4 total units broken up into 5 equal parts. So that tells me what now? Now I'm going, again, similar to the last problem, I got to go 0.8 units every time. But am I just going to go 0.8 and stop? Am I going to go 0.8 again and stop? Like I did the last one? No, because I need to reach what point? The point that breaks it up into 4 to 1. So I got to go 0.8 4 times on the X-axis. Everyone see where that's coming from? All right, so if I go 0.8 on the X-axis 4 times, that tells me I'm going how many total units? 3.2. Now, please be aware, that's not where my answer is. That's telling me how many units I need to go from the start. Where did I start on the X-axis? Where did I start on the X-axis? At point A, which was what? So at -2, I went over 3.2 units. And where did I end? 1.2 on the X-axis. That's where I ended up at 1.2. All right, now we got to get laser focused because there's a little trick here with the Y that I don't know if you guys are going to see or not. Y-axis. How many units am I going? 8. Everyone agrees? 8? Okay. 8 units total. Divided up into equal parts of 5. So how many do I need to move each time to divide it up? 1.6, yep. But it's just not 1.6 and done, right? I got to keep going until I hit that 4 to 1 spot. So how many times do I have to go 1.6? 4 times. So 1.6 times 4. How many units am I going? Look at that over here, machine. 6.4. Not where I end. That's how many you got to move. Does anybody see what's coming up here? Where did we start? On the Y-axis, where was point A? At 5, right? But watch. If you do this, 5, I go 6.4, I end up at 11.4. What's the problem? What's the problem here? Look at your darn graph. 11.4, are you kidding me? That's not even close to the line. That's way up here. What did I do wrong? Yeah, I added. What are we going? From A to B on the Y-axis, we're going down. Right? Down. So I don't want to add, I want to subtract it. Does everyone see 11.4? That's ridiculous. That's off the line. And of course it would be, because from A to B on the Y-axis, I got to go down. So we got to be aware of that. I got to subtract to get down to B. So my point is actually negative 1.4. Now, you may forget about that. Here's another way around it. Right at the beginning, remember when you told me 8 units? Aren't you going 8 units down? So you could have started out with a -8. And then all throughout, it would have been negative 6.4. There's another way around it. Okay, is if you're going down, you can have negative, you're going down 8 units, so put -8 instead. So what's my partition point here? 1.2 comma negative 1.4. I always like to take a look at the graph just to make sure I'm pretty much correct here. So 1.2 down 1, yeah, that looks pretty good. Especially 4, right? 4 to 1. 4 to 1, that looks pretty good at that point. Looks pretty darn good. You want to try one out on your own? Before we end it here, I know we got 2 more left, but so go ahead, try that next one out. Now you're, 3 to 7. How many equal parts now? 10 equal parts, yeah. And you guys are going through the tough part of it in the notes on homework tonight. Almost all of them are whole numbers. Nice, neat whole numbers for you to deal with. So you're going through the tough part right now. How many units on the x-axis are you going? Yep.
There's gonna be other quiz, right?
Yeah. This is the last topic on the quiz.
Yeah.
Is that okay?
Yeah.
Okay.
Great.
Yeah, good. I'm glad you approve. Yes, this will be on the quiz. I had the answer up there, negative 0.2, 2.2. So you divide it up equally by 10. And then you say to yourself, well, how many times do I got to go that distance? Look at your ratio. Ratio is 3 to 7. I got to go 3 times. So 0.6 3 times. And then add that or subtract it from your x value. What do you guys have? Yep, we're going 10 units, right?
Units, okay.
Divided by, no, we got 6 units. You went 6 units, right?
Yeah.
From negative 2 to 4, 6 units.
Yeah, so I
divided by 10.
Okay. So
That gives you 0.6.
Yeah.
Right? But now you're going 3 times. 0.6, 0.6, 0.6.
So it's not, okay.
So 0.6 times 3.
Yeah.
That'll give you whatever that is. And then you add that to negative 2.
Oh, so I wasn't adding the wrong number.
Yep.
Okay.
We will review everything on Monday. You guys have that Delta math if you want to practice anything. But yes, partitions are on the quiz. That's our last topic. So day 1 through 4. Yes, I'll be after today and Monday if you want to come out.
Thanks. Have a nice weekend.
See you guys.
Thank you.
See you guys.
Bye.
For what? For what? Keep it up.
Right.
Hi.
We want this.
Oh, geez.